All right, so the purpose of this video is to walk through a few things that R can do in terms of gathering a sample from a data set and also constructing a frequency table. I'm going to show some simple ways to do that within R. Now, I have open here the latest version of RStudio, which I literally just installed today, the day that I'm doing this recording. So I wanted everything to be fresh so that it all looked new. Although it still has some of my old stuff where I was looking for some help down here. Oh well. So if you have not used RStudio before, environment is divided up into four main quadrants most of the time. That is, you have up here in the upper left, this would be your script window where you're going to be writing your code. Down here in the lower left, that is, you can see it's called the console here. That is where the code will be executed and where some of the output will show up. The exception being any graphs or plots that you do, those will show up in the lower right. The upper right is, you can see there are a number of different things you can have here: environment, history, connections, and tutorial. Environment is kind of where we're going to keep it most of the time, and what that is going to show us is any of the variables or data sets that we have loaded and defined within the R environment. And then this lower right is really kind of a multi-use quadrant. So it does anything from, if you have your files in a particular location, you can see your list of files. It will show any plots that you create. It also lets you see, say, the list of packages that you have installed. You'll actually be using that a little bit later here today. It lets you see help for any of the functions that you need help on. You can just use the help function to check that. I don't know that I've ever used viewer presentation myself, but those are also options here as well. Okay, so lots of different things that can happen there in the lower right. Now, most of what we're going to be doing, though, really in terms of where the action is going to be on the left side of the screen, right? So, just so you're aware. Now, things probably look a little bit different for you. I intentionally make my windows fairly small so that it appears well when you watch the video. So for you, you probably have a bit more space in each of these quadrants as far as that goes. All right, so let's go ahead and get to it. So we really have two main tasks we want to do. First is to draw a random sample, then is to construct a frequency table. Now, there is kind of a subtask in here, and that is going to be binning quantitative data, which is something that is often very useful, especially if you're going to be making a frequency table out of that data. So let's go ahead and get into it. So the data I'm going to be using is a download from, I think it was 2016 or something like that, of the top 1,000 movies on IMDb. It's just some information about them. So let's go ahead and import that data set. So to import a data set, you would, I'm sure this is a big shock, choose import dataset right there. Now from import dataset, and in our case, I have downloaded it into an Excel file, so I'm going to be using import dataset from Excel. Now if this is your first time doing this, then odds are you're going to get a message saying that you have to update or download certain packages. Just press OK to let that happen. This is something that is going to happen several times when you're first using R. As you introduce new functions that are contained in what they call libraries, you have to download those libraries. It's fairly easy to do. You typically just kind of have to say OK, but nonetheless, that is something you have to do. All right, so now I have to find where I put this file. I put it in my downloads folder. So it says file, URL. I'm going to click browse. Now you can't see my navigation, it looks like, but it's just kind of the standard when you're navigating through, in my case, Windows, what the file navigation looks like. In my case, I put it in my downloads folder, so I look in the downloads folder, and there I can pretty quickly find, I imagine, maybe, looking, maybe not as quickly as I hope. All right, so let's go ahead and just do a quick search. There we go. IMDb movie data, that's what I want, in an Excel workbook. Okay. And click open, and then it appears here. So what R then does is it goes and connects with that Excel file, and you can see it reads things out. So a few things that you can notice immediately. One thing that it's doing you can see it has selected first row as names. So what it has done, it has taken the first row of that Excel table and decided that those are the names of the various variables. So we have here one of those rank, then title, genre, description, and there are a number of other director, actors, year, runtime, rating, votes, revenue in millions, and Metascore. So those are all that. Another thing that it's doing is telling us the data type. So you can see right here it says rank double. Now if we click on the caret here, we can see that there are a number of different possible types of data, right? So you also have the option of either including or skipping any particular column if you wish. Now I'm just going to include everything, and then we're going to manipulate it inside of R after it's already been loaded. Now, one thing you want to notice, things that are numeric, it tends to label this as double. Double is just a, I'm not going to go into the tech side of it, but it's a particular way of storing numbers in computers. Then character would be anything that would be a string, right, or letters and the like. So when you look across at rank, these are clearly numerical, numbers 1 to 1,000, where title would be listed in characters. So Guardians of the Galaxy being the number 1 at that point in time. Clearly this is a name, it's not a number. All right, other things you can look at, if you have a spreadsheet that has multiple, if you have like a spreadsheet workbook in Excel that has multiple sheets, you can select which sheet you're looking at here. Now, default, it's generally going to choose the first sheet, which for us is perfectly fine because there was only one sheet in that. Range, now this is, it again, if you have, this looks like it's grayed. Oh, so we can actually specify the range. I haven't, though. That's just an example. Okay. It's throwing me there a minute. Open data viewer, which we can see it did. Now over here, you can see this is a code preview. So what it is actually doing, this is where RStudio is doing some of the work for us, in that it is feeding this code in this little preview window into R, telling it what to do. So you can see the first thing it's doing is it has this library function. So it is reading this readXL library, which has some of the functions necessary to actually read the Excel file into R. So it's opening that library first, right, and then you can see it's using the readXL function, right, pulling from the spreadsheet, and then we'll get more into this in a minute. You can see right here, this is an assignment operator, right? So it's telling us, take whatever's in here, stick it into this variable that we'll call IMDb movie data. Now we can change this name if we wish. I'm going to go ahead and keep it IMDb movie data, but then I'm going to very quickly change it to something else. But for now, IMDb movie data is how I want it to be loaded in there. We'll get into the reasons why I'm going to be changing it later. You can see it also has this view function there. What that's going to do is going to open up a window where we'll be able to see the entire, in effect, the spreadsheet, the data table. Okay, so now that I have everything set up the way that I want it to, I'm going to go ahead and click import. Everything executes down here in the console, and then up in the upper left where our script window was before, you can see now it is displaying for us all of that data. You can see it says it's showing 1 to 3 out of 1,000 entries. There are 12 total columns. We can scroll down and then it will show different rows. Okay, so you can do that as you wish. You can also see that IMDb movie data was added over here to our environment, where it's telling us it has 1,000 observations, that'd be the number of lines, for 12 variables. So we have our data in R right now in RStudio. We're good to go as far as that goes. All right, so I'm going to go back and into the script window. So you can see this opens tabs up at the top. So IMDb movie data would be one tab. I don't actually need to see that directly right now, so I'm going to go ahead and close that. Okay, and then I'm back in my script window. So the script window is where you're going to be writing your code. Now the first thing that I want to do here, I'm going to add a little bit of comment. So to make a comment in R, you use I guess we call it the pound sign. It would be the official name of it, or nowadays we think of it as the tag sign, right? So that tells R not to read this as computer code, so that way we can then, following that, write up whatever we want. So I'm just going to go ahead and say code written by, and then I'm going to put my name, Prof E. There we go. This code was written by me. Naturally, if you're the one writing the code, you would write your own name. Now another line we're going to put here at the very beginning that is going to make our lives way easier later on is I'm going to redefine IMDb movie data, right? And I'm going to feed it into a different variable, and that different variable is going to be the one that we actually use. So we're going to call it df. df is short for data frame. The data frame is the term that they use for effectively a data table in R. So there are these technical distinctions here, but if you're like me, you're used to coming from Excel, thinking of a data frame as in effect a spreadsheet is basically going to be correct and is going to get you where you need to go. Alright, so df, then this, all we use there is the less than sign followed by a minus sign. That in effect is creating an arrow, which is the assignment operator. So what that's going to do is take whatever is to the right of it and assign that as the value of df. Now notably here, we do not use equals. Sometimes, it depends on the kind of the context, sometimes equals can be used as an assignment operator, but a lot of the time it ends up being used as a test. So if I put df equals IMDb movie data, then it's very possible the feedback that I get from R is going to be false, that it is in fact not equal to each other. So I don't want to use it as a test, I definitely want to assign, so using that, in effect, left-pointing arrow to indicate that is what I want to do. Then on the right side of it, I just need to put the name of the data frame that I'm going to be putting in there. So to start, IMDb underscore. Now this is a really nice thing about RStudio, where what RStudio will do is once it recognizes which specific data you want, it will suggest, okay, and then I lost it, comment on it, right? It will suggest anything that happens to be in the environment that matches that. So in this case, I do want IMDb movie data. This is extremely important because whenever you're coding, errors are probably going to happen. And I find in my experience that probably 9 times out of 10, errors happen just because of typos. If you don't have to type the thing, then you're not going to make a typo. Right, so that is exactly what I'm going to do here. I'm avoiding typing this whole thing because odds are something is going to happen. I'll get too many underlines in there, or I'll forget the A at the end or whatever, and that will end up ruining everything. The code won't run. So I'm just going to say, yes, that is the thing I want, click on it, and then it's going to match whatever the actual name of that data frame was. So that's the line that I need here. So when I run this, what it's going to do is create a variable, or in this case a data frame, that it calls df, and it's going to stick into that all of the information from IMDb movie data. So I'm effectively just copying that into the data frame. Now there are a few reasons to do this. One is that a lot of the time the way that you will learn to code in virtually any language, but certainly in R, is that you're going to be referring to code libraries, you're going to be looking things up online and finding code that is used. Now, a lot of the time within that code, whenever it's referring to a data frame, it will use the abbreviation df. So by taking the data frame you want to work with and just assigning it to the name df, it's going to make it way easier to implement any other code in the future. It's anything you happen to going to be the case for us here. Another thing that this does for us is that it protects the original data. So I might do some things to modify, right, this data frame before I use it. So in that case, if I'm modifying IMDb movie data, it can be difficult to recover what the original was. I'd have to go back and re-import the data set. Now, because I've reassigned it to something else, if I end up messing something up in the df data frame, that's fine. I can just redefine df assigned from IMDb movie data, and we're good to go. Right? So by protecting this original data, keeping it in its own kind of isolated space, that allows me very easily to pull it back in if necessary later on. Okay. So I'm going to go ahead and execute this code. So there are a number of options for execution up here. Right, so it says right here, run the current line or selection. That's exactly what I want to do. I'm at the end of this line, so I just click on that, and you can see it ran down here in the lower left. df assigned from IMDb movie data, and you can see now df appears here. It has exactly the same number of observations in the same number of variables. Odds are it's the same content. Now I could in fact click to open that up and see what it looks like, and there it is in my view window. It looks exactly like IMDb movie data did. All right, so now we have the data in our environment. All right, now let's actually do something with it. So the first thing I want to do is I'm going to take a sample. Now sometimes when you're dealing with really big data sets, just simply processing them can be very demanding depending on the computer you're working with. Now in this case, 1,000 observations, if I'm dealing with numerical data, calculating, say, the mean of 1,000 observations is going to be very, very fast, even for my not particularly high-powered desktop computer. It's not a quantum computer or anything like that. It can handle averaging out 1,000 numbers. That's not a problem. But nonetheless, just for the sake of demonstration, I'm going to show how we can draw a sample from that data frame that is going to then be somewhat more limited and will be random. So what this means is that from this point onward, my sample and your sample will probably look different because of the way that random numbers are generated inside of R. So let's go ahead and do this. So the first thing I want to do is I'm going to load a new library. That's a library here. Let me type that in. So library, and it's dplyr. Now one thing you might notice is that didn't come up as an option, which tells me that dplyr is not currently installed on my computer. And I can check packages over here. Packages would be just another name for the library. I can scan down, so it says user library. I don't see any dplyr here. If you scan down further, the system library, does it have dplyr? It does not have dplyr, right? So it looks like this thing I'm going to have to install. Okay, so there are really two things that have to happen here. First, I have to install the library, and then you use the library function after it's installed to tell R that you're going to be using the functions that are in that library. So, in order to install this library, what I could do, if I just run this, let's see what happens. Error in library. There is no package called dplyr. So that means I'm going to have to install it. I wasn't sure. Sometimes it might possibly say, hey, would you like to install this? This time it didn't. Okay. Right, so I'm going to go ahead over here in the lower right where I have packages selected. If you don't have packages selected, do that. And then click install. That will bring up a dialog box, which you can see here, install from repository CRAN. CRAN is just the name of the R repository that is typically used. And then packages. So I can just type in dplyr. It will notice, right there. Right, so the second one right here, dpl, it adds in the YR, click there, and install. And then it's going to take a second to go through and install things. It didn't take terribly long for me. Now, a lot of the time, packages will have other packages they're related to. So you can see here, it didn't just install dplyr, it also installed these other ones as well. Right, now, typically what will happen is that it will check to see if you have these other libraries and then only install the ones you don't have. So the more libraries you put on your computer, the shorter those install times are going to be. All right. Now there are two ways that I can activate the dplyr. One is through script. So right here in the script box, I am in that line. I can run the current line, clicking right here, and there we can see it did exactly what I wanted it to do. It says attaching package dplyr, following objects are masked from package stats. So what it's done, that's telling us that dplyr is using these things, but these things were also defined by something else, so it's overriding these. Right? So same with these. So that's really just a warning then if you were planning to use those functions, they're going to operate differently than you might expect unless you were already planning to use them in the dplyr way. Now inside of RStudio, you also have the option in the lower right that you can just click or unclick. Right? So dplyr, you can see it's checked now, it was not checked before. Well, if I uncheck it, you see it detaches it. I check it, there we go, it attached it again. Right? So simply clicking the check mark will also work. Now, I would generally recommend to go ahead and include the code, mostly because for class purposes, if you're taking my class, right, it will ensure that when you share your code with me and I run it, it runs properly because the library will be attached that way by reading the code. Right? So you're not relying on me deciding to go through and activate the dplyr library by clicking on it. Okay, so that is an important thing to do. Also, like anytime you're sharing your code with somebody else, having the library function in there is also going to be helpful. Now, there are also functions for installing packages, which you may also possibly want to use in some cases. I'm not worried about that for my course. Okay, so we have the dplyr library here, and that's going to provide us with some new functions. Now, the next thing that I want to do is sample. So I'm going to make a new variable. I'm going to call it sample df. Sample df. The assignment arrow, again, it's just less than and then the minus sign. And what I'm going to do, I'm going to put a line of code. I'll explain it here in just a second. So it's df. The square brackets are what we need for this. A nice thing about RStudio is that it will automatically provide the ending brackets or the ending parentheses whenever you need them, which is something that if you're not using RStudio, you're just programming in base R, that can be a real pain if you end up with lots of parentheses. Okay, so then df, I'm going to write sample. Okay, and see here, as I do it, I'm going to make sure, is that something that actually shows up for you as well? Awesome. Right. So you can see here a description of it. So it says, when I highlight over sample, which is what I'm going to want to use, it tells us first, this is in the base library, so we don't need dplyr for this particular function. We're going to be using it later, though. Then it says sample x, comma size, comma replace equals false, comma prob equals null. So what this will do, right? So x is going to be a list of numbers. Size is the sample size, so how many of those numbers are you going to be selecting? Replace, now when it says equals false, what that means is that the default is replace equals false, which means that it's going to be sampling without replacement. So it's not going to select the same number more than once. So once 3 has been selected, it's not going to be selected a second time. And then prob equals null. Now what that indicates is that you have the possibility of defining this prob parameter. And what that does, that allows you to assign probabilities to each individual member of x for what are the odds that it's going to get pulled. But when it says prob equals null, what that means is that we're just making them all equally likely, which is what we want to do. Okay, so we've got our function here, sample. Now we do need a left parentheses. Right, that tells us that it is a function. You can see it does provide the reminder of what it's expecting to see. Now anything that we leave blank, it will just go with the default. So in our case, we want replace to be false, we want probability to be null, so we just need the x in the size, and then we're good to go. Okay. All right, so what do we need next? We need our x. So in that case, I'm doing 1 row. So what this is going to do, it's going to read out the number of rows. We know that's 1,000, but it's going to read out the number of rows in our data frame. And then this is going to be the list of numbers from 1 to 1,000. So that is what we're going to be pulling from for our sample. And then we're going to do comma. The sample size that we want, in my case, I think I want to do 30. Okay. Right. Then here between that ending comma and the ending bracket, I'm going to add a comma. So we're going to read this right from the inside out to figure out what's happening. And I've already given some hints of some of the things that will be happening here, but I want to make sure that we have everything there. So first, the most inner thing, so if we keep going inside parentheses, this is the most inner thing. So n row df, what that's going to do is count out the number of rows in the data frame. So in our case, 1,000. Then this colon, so 1 colon another number, will provide you with a list of numbers from 1 to that. I'm just going to show this real quick. Now normally you would not be typing code in the lower right in the console, but sometimes it's okay for demonstration purposes. So I'm going to do 1 colon 5. See, it gives me 1, 2, 3, 4, 5. So in our case, it'll be the numbers from 1 to 1,000. Okay. Then move out. All right, so now we're in the sample function. So sample 1 nrow df, so we have the numbers 1 to 1,000. 30 is our sample size. So what it's randomly going to do is choose 30 of the numbers between 1 and 1,000. Now, back out another level. Okay, so this would be in the brackets. So df is the name of the data frame we're looking at. Now, what you're going to have in brackets then is your kind of what are you reading out of that, right? So if I did df1, 2, for example, I'm just going to go ahead and demonstrate that. df1, 2, using square brackets, it says Guardians of the Galaxy. So what it's doing, it is looking in the data frame, df, it's looking in that first row, so the 1 is the row, the 2 is the column, so second column. So, and then it reads out whatever that happens to be. So what this is doing, that sample function is providing it with a list of 30 random numbers for which rows it will read. In other words, it's taking a random sample of 30 of the rows out of our data set. Now we have the comma and then a blank after it. That tells it to read every single column in each of those rows. So just as another example, df, I did 2 comma and then just ended the bracket there. Out, right? And we can't see all of them, but it's reading rank, title, genre, description, directory, and then it tells us there are 7 more variables that it's reading across, which I could stretch out to see all of them if I wanted to. Okay, I know it's all based on when you first run it. All right, oh well. Right, so what this is doing is taking everything in that row for those 30 randomly chosen rows. In other words, it's making a sample for me. And that's exactly what I want it to do. So a single line, it can create this random sample. Let's run it. Ran like we wanted it to. We can see here, sample df, 30 observations of 12 variables. I could view that, and we can see these look pretty random. So it's rank 883, 731, 198, just kind of scrolling through. Yours will be different than mine, but that is the design. It is random, so that means it's not going to be predictable. Looking at mine will not tell you what yours is going to look like. All right. So the next thing that I want to do, now that I have my samples, first task done, is I want to create some frequency tables. Now the purpose of a frequency table is to show you how often certain values show up. Now we have a problem here though. Now I'm going to focus here on the numerical data. So first thing we're going to do, I'm going to focus for the purpose of this video on the runtime variable. So runtime in minutes. So we have these 30 different observations. Each of them has their own runtime, so I would like to know how frequently, right, various runtimes show up. So I want to kind of start at the beginning here. If I just try to build a frequency table on the runtime itself, I'm going to end up with too many lines, and it's not going to be informative. So let me show you why. Let's go ahead and view that sample df again. I'm going to go ahead and run over here to runtime, and then you can see what I mean. So we have 119 minutes, 119 minutes, 102, 109, 102, 121, 101, 107, 133, 148, 98, 104, 107, 96, 115, 96, and so on. So what we're going to see if we try to run it as it currently is we'll have probably somewhere in the neighborhood of at least 20 different lines, right? And we'll say, oh, well, we have 2 movies that were 119 minutes each. 1 movie was 114 minutes. 1 movie was 132 minutes. This really doesn't give us a good sense of the overall shape of the data. So what I would like to do is bin the data. And really, bin the data is really kind of what it sounds like. We can imagine, right, setting out bins or boxes, and we're going to be putting our observations in each of these boxes. So for example, we might have one box that is, how about every movie that is between 90 minutes and 100 minutes? Okay, so all of those go in one bin. And then we count up everything in that range. Then we have 100 to 110 minutes, 110 to 120 minutes, and so on. So these are the kinds of things that we may potentially want to do. Now, in order to accomplish this, we're going to have to define these bins. Now, the way we do that is with a function called cut. Right, so the cut function is going to allow us to do this. Now, the basic setup of the cut function is that you give it a data frame and variable name, and then you do one of two things. Right? You either have breaks equals the number of bins that you want, which is typically somewhere between 5 and 20, and the other option would be have breaks equals and then have a list of numbers where the numbers define exactly which breaks you're going to have. So what I'm going to do, there are a few different rules out there that you can use to determine the right number of, at least a starting point for the right number of bins. Right, so what I'm going to do here is I'm going to do that. We have 30 observations. There are two different rules. One is called Sturgis's rule, which you would usually use only if you have, say, less than 200 or so observations. Otherwise, it tends to provide too few bins. Right, so if you have 30 observations, according to Sturgis's rule, you would use 6 as your number of bins. There's another thing called Scott's rule, which, according to that, you would use 4 as your number of bins if you have 30 observations. So somewhere between 4 and 6 is where we want to go. So here's what I'm going to do. Let's go ahead and close sample out here. The first thing I'm going to do is I'm going to change this data frame by adding this bin variable to it. So here's the function I'm going to use. So df, oh wait, no, I don't want df. I'm changing the sample. So it's sample df that I'm modifying. Right. I want this to be assigned from, I'm going to use this mutate. You can see that's in the dplyr library. That's why we had to load that. Okay, so what mutate is, it's a function that will allow you to modify, you can see create, modify, or delete columns. Right, so I'm going to go add my parentheses here. The first thing that goes into mutate is which data frame you're using. So in our case, we're using the sample data frame. So sample df. Then I would put in whatever the new variable name is that I'm going to be adding, since I'm trying to add a new variable. So in my case, I'm going to call it runtime bins. There we go. And these runtime bins are going to be equal to, I'm going to use the cut function to define the bins. See, this is in the base library. And what it requires is, first, it needs to know what variable I'm going to be basing these bins on. So the first thing, to define the variable, I first need to tell it the data frame. So that's sample df, right? Then I need to tell it which variable. So to do that, you first put in a $sign that tells us to look inside of sample df, and there's my list of variables. I'm dealing with runtime, so rather than trying to type it, I'm just going to click. There we go. So I've got runtime minutes. There we are. So we're still there in that cut. Remember, we have to determine the number of the breaks. So I'm going to do breaks equals 5, so we're going to have 5 bins to start out. Okay. I'm going to go ahead and run this. Like we have an error. So what's the problem? It says argument breaks is missing. Okay, so probably what happened there is that, yes, I see what I did. Okay, so this is something that can happen. So I'm going to go ahead and delete this comma with breaks after it. What happened was that cut, these are the parentheses. So I put the comma after the last parentheses for cut. So cut didn't see the breaks got fed into mutate instead, and that caused an error. So let's go ahead and put breaks the correct place. Sorry. And then I have the choice, right? Should I cut the video and make sure everything looks perfect? No, I'm not going to, because errors happen, right? So you need to be able to read the error and say, what was it that happened here? It says argument breaks is missing. Ah, that means I probably put it the wrong place. All right, then that closes that parentheses for cut, good, and then we close the outer parentheses, and we should be good to go. Now let's try running it. Okay, it's ran. Sometimes that's the best you can hope for. Okay, it did at least run. Okay, so the question is, did it do what we wanted it to do? So there, because I have trust issues, well, first thing we notice is there are 13 variables now in sample df. That's a good sign. I'm going to go ahead and look at sample df again and scroll all the way over to the right. And there's runtime bins. Oh, excellent. So you see the bins. So there's one here for between 114 and 126, between 91.9 and 103, 103 to 114. So we have 126 to 137, 137 to 148. Okay, so we can kind of get some sense of what these bins are. Now, I have a problem though. That is that I hate these bins. They're terrible. They have a width of 11. That is not a very human-friendly number. Right? So, generally speaking, as a human being, I would much prefer that these numbers be some kind of multiple of 10 or 5, because those are easy to count by as a human being. There's no scientific reason here apart that it's easy to count 90, 100, 110, 120, whereas counting by 11s, starting at basically 92, so 92, 103, 114, 125, right? That's what we end up doing. So I would much rather prefer a different way of forming these breaks. So this is what I would like to do. I used this to find some initial breaks, but I'm going to redefine it. Okay, so we have here, we noticed the lowest number we saw was 91.9. The highest number looked to be, I believe it was 148. So what I'm going to do is I'm going to go ahead, I'm going to copy this line, that mutate line, paste it, and I'm going to change the breaks. Right, so instead of breaks equals 5, it's breaks equals, then I'm going to put a list. Now the way you make a list in R is use the C function, okay, and then we can just put in numbers with commas between them. So 91.9, I need a multiple of 10 that's going to be low enough that will capture that, so I'm going to go with 90. So there's 90, then 100, then 110, 120, 130, 140, 150. Now I believe that should capture everything that I saw, because the highest number I saw as the maximum was 148, I believe. So there we go. These are nice numbers, so we're going to have one bin that's going to be from 90 to 100, 100 to 110, 110 to 120, 120 to 130, 130 to 140, 140 to 150. Much better. So the number of bins we're going to have is basically equal to the number of commas, because those are the number of ranges. So we'll have 1, 2, 3, 4, 5. It looks like 6 bins is what we end up with in this case. So one more than I originally asked for, but that's okay, because I'd much rather have these be readable by human beings. So let's go ahead and run that. And what this will do, okay, I want to go back in just a minute. Okay. So this mutate function, what it's going to do, it does one of two things when you use it this way. If the variable that you put here does not yet exist, it creates it, which is what happened previously. If, on the other hand, it does exist, it will redefine it based on the formula you're using. So in this case, in the line we have now, it's going to take the old runtime bins and replace them with the new ones, at least. No errors, good. Now let's go ahead and check just to make sure that it did act the way I wanted it to. Again, scroll all the way over to the right. Excellent, 110 to 120, 110 to 120. And then I can check because I'm nervous. 119 is between 110 and 120. Okay, excellent. Right, so it is actually putting things in the correct bins. Perfect. Okay. All right. Now that we have all of the bins, we're ready to make a frequency table. Now, in order to make the frequency table, there are a number of ways we can accomplish this. By far the easiest one is a built-in function that exists in the library called summary tools. So I'm going to close that out here again. I'm going to do library summary tools. One thing you'll notice is that it did not suggest that I have it installed yet, because I don't. So I'm going to go ahead and install. If I try running it, let's just run it so we can see the error. There's the error, no package called summary tools. Well, we need to install it. Packages, summary tools, up, there's the option. There we are, and install. This one actually has a pretty long list of related functions. You can see that it's unpacking those here. Again, that's something that will just make our lives easier later on if we happen to need any functions that require any of these libraries. All right, so now we have the package unpacked. I'm going to go ahead and I'm just going to use the check mark on it since I know it's going to be in this list. Okay, and summary tools, there we go, check mark it, I'm good to go. Or I could have run that line. So I'm glad I have the line there so that you can see it, but there we go. Okay, so that's what I need here. Oh, yes. Okay. Now, what function do we need to create the frequency table? It's real easy. FREQ is the frequency table. So it's FREQ, short for frequency. All right, and then you can see there's a whole long list of options. Well, good news, we're not going to use them. That's going to make our lives way easier. So it says frequency X. So all X is we need to tell it what variable we want a frequency table of. So in our case, we want sample df. There we go. Add in the $sign, so it knows that it's selecting a specific variable. And I want to base this not on runtime, but on runtime bins. So in order to show you what would happen if I used runtime, let's do it wrong first. And then we'll run that and I'll show you the problem. Okay, so one, I don't like the way this is displaying. Because I have things a little bit too narrow. Right, so I'm going to widen this a little bit. There we go, that's a little better. Okay, now you see what I was complaining about before, right? In that it has here, right, the bin. Okay, it's still kind of ugly. It's much better. Okay, so the bins here are, okay, we have 192, 195, 296s, 198. That's awful and not very useful, which is why we're going to use bins instead. Right, so let's go ahead and change that. So I'm going to go up here, instead of runtime minutes, being the original data, right, it's not that hard to fix this. Okay, just scroll down further, runtime bins. And now let's try running it. And we end up with something much prettier. Okay, I'm going to need a little more space here. Now we see that in that 90 to 100 range, I have a frequency of 8, 100 to 110, I have 10, 110 to 120, I have 5, 120 to 130, I have 2, and so on. Right, so in this case, far fewer bins makes it easier for me to then see, oh, it looks like I have a lot of data in that range of 90 minutes to 120 minutes. So it looks like a good chunk of the movies that are in the database are between an hour and a half and 2 hours. Right? Now, reading out the other columns. Now this NA down here, sometimes when you define the bins, you don't choose your bounds correctly, right? So you might end up with something that doesn't fall into one of these bins. That is what the NA would do. Now, you might do this intentionally, say if there is an outlier that just has a wildly different value than everything else in your data set. In that case, you might intentionally want it to be left out so that the NA is useful for that. Usually, though, that's not the case. Normally, you want to define your bins in such a way, right, that it captures everything. Okay, but at the very least, that's what that is. Then what the different columns are. So frequency just tells you how many of the, in our case, 30 observations fit within that bin. So, as I mentioned before. The percent valid says if we ignore all of the NAs, right, what percentage, right, fit within that bin. So in this case, we can say very quickly 33.33% of the movies in our sample are between 100 and 110 minutes long. Now the percent total does the same thing, but it would also include the NAs in there. So if you do have any NAs, you would end up with a little bit smaller percentage as percent total than percent valid. Okay. Percent valid is cumulative. So that would be if you add up all of this bin and all of the previous bins, then what is the percentage? So the way we would interpret that is that 60%, right, of movies, right, are 110 minutes or less in our particular sample, right? Where 76.67% are 120 minutes or less, because that captures all of these bins together from 110 to 120, 100 to 110, 90 to 100. So it's all of those lower bins. This is something that's really, really nice if you're asking questions like, well, what percentage of movies finish in under 130 minutes? But we can answer that immediately by looking at that percent cumulative frequency. Yeah, or cumulative relative frequency would be another name for that we would use. But what if the opposite? What if you want to know what movies are long? Well, there are a couple ways to do that. One would be to simply use the kind of 100% minus rule, so we know 100% of movies exist. If 83.33% are 130 minutes or less, then it must be that 100 minus 83.33, that comes to 16.67%, right, have to be longer than 130 minutes. That works. But there is another thing we can do that can make our lives a little bit easier and actually rearrange our this table so that it will go, instead of from the smallest bin to the largest bin in terms of the order of the rank, of the order of the numbers, we can go the other way around, right? So it goes from 140 to 150 to 130 to 140 and so on. So it's descending rather than ascending. So to do that, we need another library. Come back up here, library. This one is called forcats. Looks like we're going to have to install this one as well. Right? We're getting good at that. Forcats. This is like forecast, but the T and S are inverted. Go ahead and install that. Right? And this, it's going to have a very simple function here for us. So I'm going to copy this frequency table. Copied that down here, and now what I want to do, instead of doing this, I'm going to add one more function before the sample name, and that is fct underscore rev. And then we need to make sure we have enough parentheses to finish everything out. So the first thing this is going to do is it's going to take our runtime bins, which actually have built in them, they use this term called factor, right? So a factor in R is something that has some clear order to it, right? So it's something that may look like a string rather than a single number. So that range 90 to 100, right, that's not just one number. It is actually read out as a string. You can also have factors with names like excellent, good, average, poor, and the like. Right? So once you define a factor, you can define the order of these things. So one of the things that happens with that cut function is that it defines the order, and it defines the order of the bins that it makes in numerical order ascending. So what fct-rev does is, you can probably figure out where it's going, it's factor reverse, right? So it takes that order and flips it around. So what's going to happen here is that it's going to take the order that is built in, right, to these bins, and it's going to reverse them. So what is high is low and what is low is high in terms of how it's thinking of the ordering of them, and then read that all into the frequency table. So we'll get the same output in terms of these first two columns, right? Except it will be reversed. So we'd have 140 to 150 first, then 130 to 140, and so on. And so the frequencies will be the same, so it'll just be 1, 4, 2, 5, 10, 8. And the percent valid would also be the same, but again, just reading from bottom to top. What will change is this percent valid cumulative, right? So the cumulative, because it's adding as it goes, if you reverse the order, it's going to change those percentages. So let's go ahead and run that to show what that looks like. It could not find the function. Oh, because I forgot to turn the library on. It run the library, there we go. Now the library is actually loaded, so it can find the function, and here we are. And it did exactly as predicted. Right, so we have frequencies 1, 4, 2, 5, 10, 8, right, percent valid exactly flipped from what it was in the previous, and percent valid cumulative, you can see it's now counting up. And one way you can check this is that in the first line it should be the same as your percent valid. After that, it should just be whatever the previous line was plus the new percent valid. So 3.33 plus 13.33 gives us the 16.67. Plus 6.67 gives us 23.33, and so on. And then we can answer the simple questions like, what percentage of movies in our sample are over 130 minutes long? Oh, there it is, 16.67. Right? Because I am accumulating from the high to the low, the 16.67 tells us how many are in this bin, so that means 130 to 140, or a higher bin, so 140 to 150 in this case. Okay. So that is how we can, within RStudio, first take a sample, secondly, bin our data for use in frequency tables, then we can make the frequency table and we can choose, right, would we rather have it ascending in value, being what it would automatically do, or we can reverse it and make it descending in value. Now, a lot of this stuff, I really think of this from the technical standpoint, there really isn't a whole lot here, right? It's not particularly difficult, right? So we have to assign our data in, create the sample. Really, we could have done that. Create the sample, that was just a single line. Then binning, I did 2 lines because I wanted to preserve both the original break and also kind of my modified breaks just so we could see. Then another line for the regular frequency table in ascending order, another line for the frequency table in descending order. That's it, right? So it doesn't take a whole lot of programming to get this to do what you want it to do, as long as you have the right functions available to you. It turns out R is a very popular program. Lots of people have been making functions. So with some searching, you can often find the functions that you want. So one thing, though, that R can't do for you is answer some important questions. Like, 1, what breaks should you use? That's something where I, as a human being, had to come in and say, wait a minute, I like having multiples of 10. I find that easier to read, and I think that's true for most human beings. We find multiples of 10 easy to process, or multiples of 5 to be easy to process. Right? So trying to maneuver these breaks around, right, so that they are more human-friendly is something that R is not smart enough to figure out what that's going to look like. Tell it what breaks you want, it can very easily churn the data for you. That's not a problem. Similarly, should we have this in ascending order or descending order in terms of the bins? Well, that's going to depend a lot on the questions you want to ask. R doesn't know what questions you want to ask. So it's really up to you as the human being to come in and say, okay, in this case, in this context, it makes sense for me to form bins in a certain way and to list them in a certain order when I make the frequency table. So this is where like analytics has both kind of the sciencey aspects, the programming aspects, the technical aspects, but also the more human, artsy kind of aspects, where we need to think about how we're communicating the numbers that we're dealing with. And even little things like what order should we put our bins in is something that can make it easier or harder to answer specific questions. So I'm going to go ahead and wrap the video here. Now certainly you can go through and you can make frequency tables as well for the other numerical variables here. Like if you are taking my class, for example, or if you're not taking my class, you can go through and say, okay, what about ratings? So these movie ratings there, you could also create frequency tables for that. Similarly for the number of votes that they get. And then look at the distributions and see what kind of information you get just from looking at the frequency table alone. Okay, so I'm going to go ahead and wrap the video here. Thank you for your attention, and happy analyzing.